Chapter 8 deals with a new concept to you called logarithms, something you have not studied before. It's a new notation that you haven't encountered before, but it is heavily based on exponential equations and functions that you learned last day or last chapter. There's a lot of relationship between the two. Logarithms have a very universal application. They're not just used in math. In fact, to be completely honest, the logarithms that you learn in this chapter aren't really the logarithms that you use in calculus. It's like I'm spending a whole chapter lying to you. Well, not really, I guess. The logarithms that you use in calculus are called natural logarithms for the most part. These ones, or this form of logarithm, I should say, are used in like chemistry and biology and geology. Okay, I'll talk more about that later, but yeah, they have some pretty cool applications. You guys know pH. When you measure like the strength of an acid or a base, you give it a number between 0 and 14. That scale is a logarithmic scale. Okay, or you know the Richter scale to measure the intensity of earthquakes, also a logarithmic scale. Okay, so it has some very universal applications. It's pretty cool stuff. Before we start graphing things and looking at equations, I'm just going to try to explain basically what a logarithm does and what it is. Okay, so consider the equation 2 to the 3 equals 8. Right, this is just an exponential equation. 2 to the power 3 equals 8. We could take that exponential equation and we could write it in logarithmic form by doing the following. Okay, we could write it as log 8 with a base of 2 equals 3. Okay, can you see where each of these components up here went? Where did the base of the exponent go?
Right next to the log.
Yeah, it became the base of the log. The smaller number down here, we call that the base of the logarithm. Okay. The exponent up top, where did that go?
The product.
That's what the logarithm is equal to. Okay. And then the 8 became the argument inside the logarithm function. Okay. So all you're really doing when you're working with logarithms is you're taking an exponential equation and you're reordering it. You're changing places or changing the location of different things. And this makes some potentially difficult exponential equations solvable, which you'll learn about later on. Just to confirm that this actually is true, take your calculator and in your calculator type log, it'll come up with a bracket, 8 divided by log with a bracket 2. Okay, type that into your calculator and tell me what you get.
3. Oh. Come on.
Okay, did you get 3?
Yeah.
Good, that's a little bit of a confirmation. Okay. In general, we can take anything in exponential form, namely, if I go like a to the power of b equals c, I can take that in what we call exponential form, and we can turn it into logarithmic form. By taking the base of the exponent and making that the base of the logarithm. So log, and then the a goes down below. The exponent itself goes on the right side, just like last time. Is that right? Yes. And then what that was equal to becomes the argument of the logarithm. Okay. This conversion right here is super, super important. Okay, it's probably the most important thing that I'll say today. Understanding how to convert between exponential form and logarithmic form and back. Because when you start evaluating logarithms, when you start especially solving logarithmic equations, knowing this relationship between exponential and logarithmic and being able to do that conversion is very, very important. Okay, it's always the base that I go back to when I kind of forget what to do when I'm trying to convert an exponential expression into a logarithmic one. This conversion always saves me. Okay, so don't forget that. That's very important.